Questions 11 through 20 on the 2007 Grade 12 AMC 12B. The angles of a quadrilateral ABCD satisfy A is equal to 2B equal to 3C equal to 4D. What is the degree measure of angle A rounded to the nearest whole number? Well, the angles have a relationship as shown in the question stem. And we know that in a quadrilateral, the sum of all the angles will be 360. A quadrilateral is essentially just two triangles. So since a triangle is 180 in terms of the sum of the angles, quadrilateral will be 360. So let's solve for this. Let's put everything in terms of one variable. Very quickly, I see A is equal to 4D, B is equal to 2D, and C will be equal to 4D over 3, and then D, and that is 360. So this will allow me to solve for D, and then I can solve for A later. So this looks like 7D plus 4D over 3 is 360. If you add this fraction, you get 25 over 3, and that's D. Solving, we get 25D is equal to 1080, and therefore D will be 43.2. And since A is equal to 4D, A will be equal to 172.8. Rounded to the nearest whole number, it's 173. So the answer to number 11 is D. A teacher gave a test to a class in which 10% of the students are juniors and 90% are seniors. The average score on the test was 84. The juniors all received the same score. The average score of the seniors was 83. What score did each of the juniors receive on the test? So let's just say there's 100 students in total. That would mean there's 10 juniors and 90 seniors. And the score that each junior gets, let's just call it X. They all receive the same score. And the average of the seniors is 83. So mathematically, this is 10X plus 90 times 83 all over the total number of students, and that average is 84. Solving, we get 10X plus 7470 is equal to 8400, and therefore X is equal to 93. So number 12, the answer is C. A traffic light runs repeatedly through the following cycle: green for 30 seconds, yellow for 3 seconds, and then red for 30 seconds. Lee picks a random 3-second time interval to watch the light. What is the probability that the color changes while she is watching? So it's green for 30 seconds, so 1, 2, 3 seconds, dot, 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 all the way until you get to 30 seconds. And then yellow for 3 seconds, 1, 2, 3, and then red for the next 30 seconds. So 1, 2, 3, dot, 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 all the way till 28, 29, 30, like that. And then it goes back to being green again, 1, 2, 3, and so on. So the light will change at these points right here, from green to yellow, from yellow to red, and then red to green. Now, the total segment, if we were to look at it from the perspective of the total number of seconds, from here to here is 30, this is 3, and this is 30. So that is 63 seconds in total. So with regard to Lee and her 3-second time interval, the light will change if the beginning of her interval lies, for example, between 28 and 30. If you look at that segment, if her interval starts anywhere in there, she will eventually cross over to a point where it's yellow. And similarly, if you look at the next time the light changes from yellow to red, that's going to be from 30 seconds until 33 seconds. If her interval begins in that range, she'll be able to observe the light turning from yellow to red. And finally, the last one, which is red to green in my 63-second interval, is basically going to happen if her interval begins within this range, 60 to 63 seconds. So that's a total of 9 seconds, 3 from here, 3 from here, and 3 from here, and 9 seconds out of the total range, which is 63. So that becomes, if you reduce it to lowest terms, 1/7. So that's the probability that the color changes while she is watching in any of her 3-second intervals. So number 13, the answer is D. Point P is inside equilateral triangle ABC. Points Q, R, S are the feet of the perpendiculars from P to AB, BC, and CA respectively. Given that PQ is 1 and PR is 2 and PS is 3, what is AB? So we will try to draw this. So I'll choose a point and make that my P. So this point right here I've called P, and the feet therefore are Q here, R here, and S here. And of course the triangle is ABC and it's equilateral. And the side length I don't know, so I'll just call it X for now. And then later we can see what X equals. I think that's what they're trying. Yeah, AB, that is what they want us to figure out. Okay. So let's label the PQ, which is 1, PR, which is 2, and PS is 3. Now, how are we going to approach this question? With this information that the question gave me, how can I figure out the value for X? What you do is you draw lines from P to each of the corners. And when you do that, you will see that it splits up into 3 triangles. The 3 triangles are APB, that guy, APC, and this one right here, BPC. Now, if you treat each of those triangles as a separate unit and calculate its area, if you add them all up, it will equal the total area of ABC. So the area of triangle ABC is the area of triangle APB plus APC plus ABPC. Okay? Now each of these triangles, we can figure out the area pretty quickly because we know the base and we know the height. So for APB, it's 1/2 base, which is X. The height is 1. For APC, the base is again X. And the height this time is 3. And for BPC, the base is X and the height is 2. So simplifying, we get X over 2 plus 3X over 2 plus X. And this equals 3X. All right, so we got 3X is equal to that side. Now I have to figure out the area of ABC in terms of X, and if I do, then I can solve for X. So how do I do that? Well, I'll draw this equilateral triangle again. And this time I will draw a line from top to bottom like that. And just as before, the sides have the length of X. It's the same triangle. But this is equilateral, so this is 60 degrees. And this perpendicular makes that 90, and therefore this is 30. And therefore this is X over 2. So in a 30, 60, 90 triangle, we know the ratio of the sides are 1, 2, and root 3. So if I want to figure out this height, I can just use the ratio. H over x over 2, if I'm comparing those two sides, will be equivalent to root 3 over 1. So therefore h is equal to root 3 times x over 2. So the area of ABC using this diagram is going to be 1/2 base, the base is x, times height, which I just calculated as root 3x over 2. So there you go. This is the equation that will help me solve for x, which is what they want. So we get root 3 over 4 x squared is equal to 3x. Divide both sides by x, get rid of that, and that leaves me with just root 3 over 4x is equal to 3, and therefore x is equal to 12 over root 3. Most likely they want you to rationalize the denominator, so multiply top and bottom by root 3. That will give me 12 root 3 over 3, which is 4 root 3. 4 root 3 is my answer, and therefore number 14, the answer is D. The geometric series a plus ar squared plus dot 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 has a sum of 7. And the terms involving odd powers of r have a sum of 3. What is a plus r? In an infinite geometric series, which is what this is, it keeps on going forever, the sum is equal to a over 1 minus r. So it's a cool little formula. But this is only true if r is less than 1. All right, because if r is greater than 1, obviously we're going to get a negative answer, and that wouldn't make any sense. So that's the first one. And they tell you that it's equal to 7. So that's our first equation. A over 1 minus r is equal to 7. So a equals 7 minus 7r. And then the next sentence, they tell me that only odd powers of r, if you look at those, that has a sum of 3. So what that basically means is now you have the following geometric series. You have AR plus AR to the power 3 plus AR to the power 5, dot, 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 like that. And they're saying if you add all of these up, it equals 3. So if we use our formula again, A is the first term. So AR, that's what goes here, the first term. And the first term in this series is AR. And then 1 minus the ratio. What's the common ratio here? It's not R. The ratio is found by taking the second term and dividing it by the first term. And that gives me R squared. So my ratio in this is R squared. And that, they tell me, is equal to 3. So this gives me my second equation, which is AR is equal to 3 minus 3R squared. Okay, so those are the two equations. This one and this one. And we will use these two equations to solve for R, solve for A, and then we can add up A plus R. So let's substitute A is equal to 7 minus 7R into here. So if I do that, I get 7 minus 7R times R is equal to 3 minus 3R squared, like that. This becomes 7R minus 7R squared is equal to 3 minus 3R squared. And therefore, if you put everything on one side, this becomes 4R squared minus 7R plus 3 is equal to 0. And there's no obvious factors for this as far as I can see, so I'll just use a quadratic. Shouldn't take that long. Minus b plus or minus square root of b squared minus 4ac all over 2a. And that gives me minus 7 plus or minus 49. And then 16, that's 48. And that's all over 8. And that's going to give me 7 plus or minus 1 over 8. So that gives me 7 plus 1 is 1. 7 minus 1 over 8 would be 6 over 8, which is 3 over 4. Okay, so those are my values for r. But remember, r has to be less than 1, so the only value of r that's possible is 3 over 4. All right, we can easily now plug it back into here to find a. A is 7 minus 7r. R is 3 over 4, like that. So we got 7 minus 21 over 4. Let's add this fraction, top and bottom by 4. So we got 28 minus 21, which is 7 all over 4. So that's the value for A. So A is 7 over 4, and R is 3 over 4. So they want us to find A plus R. So A plus R is 7 over 4 plus 3 over 4, which is 10 over 4. And in lowest terms, that's 5 over 2. So the answer to number 15 is E. Each face of a regular tetrahedron is painted either red, white, or blue. Two colorings are considered indistinguishable if two congruent tetrahedra with those colorings can be rotated so that their appearances are identical. How many distinguishable colorings are possible? Distinguishable, meaning unique. So very quickly you can find the indistinguishable, right? Because you've got 4 sides of a tetrahedron, and you've got 3 colors. So for the first, you can choose any of those 3 colors. For the second side, any of those 3 colors, and so on. And if you multiply them all, you get 9 times 9, which is 81. These are the number of indistinguishable tetrahedra. And that is one of the choices. But they don't want indistinguishable, they want distinguishable. So it's a little bit different. That's fine, we can look at this by casework. If all the sides are the same, then that means we have either red, 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 blue, 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 like that, or all white. And if these are the scenarios, we have 3 possible ways of doing that. Okay? The next is if you have 3 sides the same and 1 different color. So for example, you have red, 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 and then say blue, and then red, 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 white. That would work. And remember, I'm looking for distinguishable, so I don't need to include something like this, red, red, blue, red, because this is indistinguishable to that. You see what I mean? Because it can be rotated exactly the way the question is talking about. So we want unique possibilities, combinations. The next one is if you have 3 blue, and then the last one could be either red or white. And of course, 3 white, like that. And the last color can be red or blue. So for this one, we got 6. All right, so far so good. Okay, keep going here. The next scenario is if you have 2 that are the same, and then 2 more that are the same. So for example, 2 red and 2 white. 2 red and 2 blue, or 2 blue and 2 white, like this. There's 3 of these possible in terms of unique. We don't want the combinations, like for example, red W, because this is the same, because it can be rotated to look the same. And then finally, the last scenario is 2 same, but then 1 different, and then another one different. So for example, it would be red, red, W, blue, or W, W, red, blue, or blue, blue, and red, white, like that. And that gives me another 3. And that's it. The good news is we're done. So the total is what? Here, 15. So there you go. That's the answer to the question for number 16. So that would be choice A. If A is a non-zero integer and B is a positive number such that AB squared is equal to the log of B to the base 10, what is the median of the set 0, 1, AB, 1 over B. So the best way to approach this is by casework, and here we go. So the first thing, I have no idea what is B, the value for B, right? Or the value for A. So since it's talking about base 10, I'm going to start with base 10 number. Start simply with B equals 10. And we'll see what we get. If B equals 10, then this equation becomes A times 100 is equal to the log of 10 to the base 10. That means A times 100 is equal to, well, this is just 1, so A is equal to 1 over 100. But that's a problem. Why? Because A is a non-zero integer. Very key point to this question that a lot of people will, well, not a lot of people, but some people might miss. So unfortunately, B cannot equal 10. No problem. Let's try B equals 1. See what happens. That would make my equation A times 1 squared is equal to the log of 1 to the base 10. So that means A is equal to the log of 1 to the base 10. So 10 to the power of A is equal to 1. That means A is 0. But again, that's a problem because A is non-zero. So B can't be 1. All right, no problem. Let's keep going here. Keep going in the other direction. How about 1 over 10, which basically would be 10 to the power of negative 1. See what we get. That would give me AB squared, which it would be 1 over 100 is equal to the log of B, which is 10 to the minus 1 to the base 10. This looks like negative 1 to the log of 10 to the base 10 is equal to A over 100. And this is just 1, so this just becomes negative 1, A over 100. And therefore, A is equal to negative 100. Is that good? Yeah, that's an integer. It's a negative, but it's an integer. So we got A as a non-zero integer right there. And is B a positive number? Yes, it's positive. So there we go. We got a condition that makes the sentence in the question true, hold true. So now we have to look at these numbers and figure out the median. So those numbers are 0, 1, A, B, and 1 over B. Well, for us, it's 0, 1. Our A is minus 100. Our B is 1 over 10. And 1 over B would be 10. So let's arrange this from smallest to largest. So minus 100 would be our smallest. And then I think 0. And then 1 over 10. And then 1 and then 10. The median of this is the middle, which is right here. And that represents which of these letters? It represents this guy right here, B. So number 17, the answer is B, which is choice D. Let A, B, and C be the digits with A not equal to 0. The 3-digit integer ABC lies 1/3 of the way from the square of a positive integer to the square of the next larger integer. The integer ACB lies 2/3 of the way between the same two squares. What is A plus B plus C? So if we have a number line and we divide that number line, I guess, into segments of 3, so approximately here and here, they are basically saying that you've got some square, so let's say m squared like this, and then on the other side you've got another square, but it's the next integer's square, so m plus 1 squared. Okay? And then 1/3 of the way, so right here, you've got some number that is of the form ABC. And then 2/3 of the way, which is right there, they've got another integer, which is of the form ACB. And they want you to figure out A plus B plus C. Okay, so let's proceed with this. I have no idea what these numbers are. The only thing I know that this is 1/3 of the way from there to there. So I will call that x. And therefore this is x, and therefore this is x, right? So we know that m plus 1 squared minus m squared is equal to 3x. Correct? No tricks so far, and I hope there won't be any tricks either. So if you expand and simplify the left side, you'll get basically m squared plus 2m plus 1 minus m squared is equal to 3x. And therefore, this just becomes 2m plus 1 is equal to 3x. Okay, so far so good. And then you can, if you want, you can write x is equal to 2m plus 1 over 3. I don't know if that's going to help, but we'll see. Now we turn our attention to the fact that this minus this is x. They are x apart, right? And this number is obviously greater than that number because it's closer to the bigger number. So it's kind of like that. So over here I will write ACB minus ABC is equal to x. Now what is ACB? It's a number, like for example 512, something like that. But 512 is really 500 plus 10 plus 2, correct? So we have to write that form here. So 100A plus 10C plus B, like that. And then similarly for ABC, it's 100A minus 10B minus C, because we are subtracting. This gets rid of the A's, and we are left with just 9C minus 9B is equal to x. Factor out the 9, you get C minus B is equal to x. All right, so that tells me that x is a multiple of 9, correct? And since x is a multiple of 9, 3x is a multiple of 27. So if you look at this equation right here, 2m plus 1 is equal to some multiple of 27, so 27k. Got it? So no tricks really. This is just straightforward mathematics. Now I've got to figure out my value for m, but I have a huge clue that it's a multiple of 27. 2m plus 1 is a multiple of 27. So let's just start with k equals 1 and see what I get. If k is 1, that means 2m plus 1 is 27. And therefore 2m will be equal to 26, and m is 13. Okay, m is 13. I think that will be very helpful. Let's see if this works out. If m is 13, then 13 squared is 169. Let me reproduce that number line down here and see if everything matches up. If it doesn't, we can always try again with k equals 2. Now, m is 13, so m plus 1 will be 14. 14 squared is 196. So the distance from here to here is 169 to 196, which is 27. So if I were to break it up into, segments that are 1/3, this is 9, and this is 9, and this is 9 in terms of its length. So this number that goes here, which is ABC, is basically 169 plus 9, which is 178. Okay? The number goes here is ACB, and that's 178 plus 9, which is 187. Great. 78, 87, perfect. This matches. I'm done. So my ABC is 178. They want me to find A plus B plus C, and therefore that is 1 plus 7 plus 8, and that is 16. So number 18, the answer is 16, which is choice C. Rhombus ABCD, which has side length 6 is rolled to form a cylinder of volume 6 by taping AB to DC. What is the sign of ABC? Now, the first thing you might say is that possible? Can we do that? If you have a square, for example, then yeah, it's very easy to visualize that you take one side and you just tape it to the other side, and then that would make a cylinder. But if I have a rhombus, how is that going to work? Because a rhombus is sort of a different shape. It looks like this, right? Or it looks like this. Is that possible? And the answer is yes, it is possible. So let's draw it out and I'll explain. So here's A and B and C and D. And the rhombus has all sides the same, right? So not perfectly drawn to scale, but you get the idea. So we are taping AB to AC. So, I totally encourage you, if you need to, get out a piece of paper, draw the shape, cut it out, tape it, and see how this works. Nothing wrong with that. Visualization, if it's aided through some prop, anything that you have. Obviously, you can't do that on a math contest unless you're allowed to bring tape. But you can actually draw it out and then fold it on a piece of paper. So if you do that, what happens is that you get the following kind of shape. So you get a cylinder, something like that, right? But I'm going to now draw in a very important line which represents AB, but I'm going to draw it on the cylinder. AB will look something like this. All right? It's not going to be a cross because it's not a square. It's a rhombus. So that is not extremely difficult, but I think that's obviously the most challenging part about this question. Now they want you to figure out the sign of angle ABC. Well, angle ABC is here, right? But where is it here? This is A, and this point right here is B. So angle ABC here is this angle right here, the angle that it makes with that side. All right? I've drawn these, I guess the circular part of it. But if you were to draw this in a way that it looks completely flat, it will look a little bit different. And that might make a little bit more sense to you that that's AB. Okay, and this is angle ABC. All right, so here we go. We have to first figure out a few things, and then we can figure out the sign of ABC. So the first thing, of course, is we have to figure out the height. The height, which is basically from here to here. That is needed. Well, they give us some clues, right? They tell you that the volume of the cylinder is 6. So how do you figure out the volume of the cylinder? It's pi r squared times height. They tell you that volume is 6. Now, r is what? R is the radius of that circle right there. So that's r. Now, how do we figure out r? Well, this whole thing is the circumference. And that circumference was created basically by folding this. So that circumference is the same length as BC. So circumference is equal to pi times diameter, which is pi times 2 times the radius. And the circumference in this case is equal to BC. And BC is 6 because this rhombus had side lengths of 6. So there we go. This will allow me to solve for r. So r is basically 3 over pi. Substitute that r into here. We got 3 over pi all squared is equal to h. And this allows me to solve for h. So h becomes 6 pi 9 over pi squared times h. So this becomes 6 pi over 9. And in lowest terms, that will be divide top and bottom by 3, and you get 2 pi over 3. And that is the value for h. Now we get to the sign of ABC. And we will now use this diagram right here. The sign of an angle is opposite over hypotenuse. So in this triangle, the opposite is from there to there, which is essentially represented by h. It's the height of that cylinder. So h goes here, and the hypotenuse is right here, AB. So over AB, like that. H we just found was 2 pi over 3. AB is 6. So this becomes 2 pi over 3 times 1 over 6. And that is 2 pi over 18, or just pi over 9 in lowest terms. So number 19, the answer is A. The parallelogram bounded by the lines y equals ax plus c, y equals ax plus d, y equals bx plus c, and y equals bx plus d has an area of 18. The parallelogram bound by the lines y equals ax plus c, y equals ax minus d, y equals bx plus c, and y equals bx minus d has an area of 72. Given that a, b, c, and d are positive integers, what is the smallest possible value of a plus b plus c plus d? So the first step in this question is let's draw a diagram so that I can explain this. So here is my diagram approximately, and I'll label these. This line right here, that guy, is y is equal to ax plus c. Okay, that green line. And then this line right here is equal to y is equal to bx plus c. And then this line here is equal to y is equal to bx plus d. And finally, this line up here, that guy, is equal to y is equal to ax plus d. And let's clean this up a bit, because I don't think we need a lot of these lines here. This one I'll clean it up, that one I'll clean up. And that means that this parallelogram that is remaining is the parallelogram that we have to discuss. So it's basically this shape right here. There, 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 and there. That parallelogram. Okay? So now let's begin. The first thing, of course, is we have to figure out some of these points. If we can't figure out the points, then it'll be impossible to solve this. So let's start by labeling them. This point right here, I'll call A. This point right here, I will call B. This point right here, I will call C. And that point of the parallelogram, D. So here we go. Let's first start with A. Try to get the coordinates for A. Well, A is the intersection of which two lines? This one and this one, right? So that would mean AC plus C, AX plus C is equal to BX plus C. The C's disappear, so you get 0 is equal to BX minus AX, and therefore A minus BX is equal to 0, therefore X must be 0. Because A cannot equal B, right? Because if A equals B, then this line and this line would be identical lines. They're not identical lines, they're different lines. So that means X equals 0. So A, the coordinate is 0. But what's the Y coordinate? Well, substitute back into any of these lines and you get that Y is equal to C. Alright, so far so good. So we got A. Now let's concentrate on, well, let's do C. I think C should be relatively straightforward. C is the intersection of this line and this line. So that means that BX plus D is equal to AX plus D. And in a very similar way, AX minus BX is 0. A minus BX is 0. And therefore X is 0. So that means this is 0. And then the Y coordinate I get by substituting back into either of those. And that's just D. Okay, so far so good. All right. Now let's concentrate on getting B and D, these ones. B is the intersection of this guy and this guy. So that's going to be AX plus C is equal to BX plus D, right? So that means AX minus BX is equal to D minus C. So that means X is equal to D minus C over A minus B, like that. So this basically means that my coordinates for B, for at least the X coordinate, is D minus C over A minus B. And the Y coordinate I don't think I will need, so I'm just going to leave it as Y1. And then finally this, what have I got? A, B, C, I need D, right? D is my only one that's left. Y2. So D is the intersection of this line and this line. So that means this will be AX plus D is equal to BX plus C. And therefore AX minus BX is equal to C minus D. And therefore C minus D over A minus B is equal to X. So there we go, C minus D over A minus B. So I've got all 4 points. Okay? So I've got all 4 points, so now I can concentrate on the area formula. Now the area, they have told me, is equal to 18. This area is 18. But notice, this is really 2 triangles. We got one triangle like this, and then one triangle like that. Right? Any parallelogram could be broken up into 2 triangles. So instead of looking at it from the perspective of a parallelogram, I'll look at it from the perspective of 2 triangles. So instead of a parallelogram with an area of 18, I'll look at it as 2 triangles with an area each of 9. So 9 is equal to 1/2 base times height. Now I have to carefully explain which one is the base and which one is the height. So if I am looking at this triangle right here, the base will be from C to A. Okay? So 1/2 from C to A. That's my base. And then the height is going to be a perpendicular distance from D till the y-axis like that. Okay? So that's going to be my height. I'll just call that H. So let's go back and substitute that in. 9 is equal to 1/2. CA is the distance from here to here. Well, C is 0D in terms of its coordinates, and A is 0C. So the y coordinates are D and C, so the distance is just D minus C. H is the distance from here to here, which is essentially just the x-coordinate of D. And the x-coordinate of D is C minus D over A minus B. Correct? From here, from right there. So there we go. Put that in there. It's C minus D over A minus B. And that is going to help us with this question. So if you work with this, you get that 18 times A minus B, if you cross multiply, is equal to C minus, or rather D minus C squared. And I had to bring out a -1, so I'll transfer the -1 over here to make that B minus A. So this is mathematically valid. No mistakes. Now in a very similar way, we can do the exact same thing for the second parallelogram. And if you do that, I'll skip over all the work because it's exactly the same as what I just did for the first parallelogram. That will give you 72 this time, because that was the area of the second parallelogram they describe in the question. B minus A is equal to D plus C squared. And like I said, the work involved to get that is exactly what I just did here. So for the sake of time, I'll just leave that out. I'll let you do that. So there we go. I'll call this equation 1. I'll call this equation 2. Now we have to combine these. Equation 2 minus equation 1 will give you the following result. It will give you 54b minus a. And on the right side, we'll expand this out. D squared minus 2cd plus c squared minus d squared minus 2cd minus c squared. And that leaves me with just 4cd is equal to 54b minus a. And if I divide through by 2, I get 2cd is equal to 27b minus a. All right, we're almost done here. So this basically means that b minus a is even because it's equal to 2 times something. So that means if we want to minimize, we can let a equal to 1 and b equal to 3. If we do that, b minus a becomes 2, and that's the smallest possible value because we're interested in the smallest possible value of a, b, c, and d. Similarly, if you look at this equation, cd is a multiple of 27, and that makes sense to minimize it with the following numbers: c equal to 3 and d equal to 9. If you do that, you get 27, which is the smallest possible multiple of 27. So there you go. Those are my values for a, b, c, and d. And therefore the sum, which is what they want, a plus b plus c plus d, will be equal to 1 plus 3 plus 3 plus 9, which is 16. So the answer to number 20 is 16, which is choice D.